Hello and welcome to the channel Science, Maths and Engineering. Today we are going to solve the APSC Irrigation 2021 Mechanical Engineering paper. So let's get started. Question number 1. In gears, pitch circle is A. The imaginary circle which by its pure rolling action produces the same effect as the actual gear under reference. B. The circle passing through the top of the teeth. C. The circle passing through the bottom of the teeth, or D, also termed as base circle. So you can pause and think of the answer. So the answer is A. Pitch circle is the imaginary circle which by its pure rolling action produces the same effect as the actual gear under reference. Now the circle passing through the top of the teeth is called addendum circle. The circle passing through the bottom of the teeth is called dedendum circle. It is also called root circle. And base circle is a circle of radius r cos phi, where r is the radius of the pitch circle and phi is the pressure angle. So in case there are any doubts, you can follow the source. This is from Theory of Machines, so you can follow the source and check it out. So we will go to the next question. The function of governor is to A. Control the speed variation by the fluctuation of turning moment during a cycle. B. Keep the variation in mean speed of the engine within prescribed limits due to fluctuation in load over a period of time. C. Regulate speed during one cycle only. Or D. Store energy and give up the energy whenever required. So you can pause and think of the answer. So the answer is the function of a governor is to keep the variation in mean speed of the engine within prescribed limits due to fluctuation in load over a period of time. So even if there are fluctuation in the loads, the governor will try to keep the variation within a mean speed. So it will try to maintain the mean speed. While here the options A and D are the characteristics of a flywheel. So in case there are any more doubts, you can follow the source. So we'll go to the next question. An example of spring control governor is A. Watt governor, B. Porter governor, C. Hartnell governor, or D. Proel governor. So you can think, you can pause and think of the solution. So the answer is C. Hartnell governor. Now Hartnell governor along with Hartung governor, Wilson-Hartnell governor, Pickering governor are all examples of spring control governor. Here Pickering governor uses 3 leaf springs. Okay. So we will go to the next question. If the helix angle of square thread is alpha and friction angle is phi, the efficiency of screw jack is A. Tan of alpha plus phi by tan alpha, B. Tan of alpha minus phi by tan alpha, C. Tan of alpha by tan of alpha plus phi, or D. Tan of alpha by tan of alpha plus tan phi. So you can pause and think of the answer. So the answer is C. Tan of alpha by tan of alpha plus phi. Okay. So you can follow the source if in case you have any more doubts. So we'll go to the next question. The frictional torque at a flat pivot bearing assuming uniform pressure theory is A. 0.5 mu Wr, B. 0.67 mu Wr, C. 0.75 mu Wr, or D. 0.25 mu Wr. So you can pause and think of the solution. Okay. So the solution is B. 0.67 mu Wr. So now see, this is a flat pivotal bearing and we are assuming uniform pressure theory. Now when we are using uniform pressure theory, the frictional torque is T is equal to 2 by 3 mu Wr, which is equal to 0.67 mu Wr. However, in case if you are assuming uniform weight theory, then the frictional torque would be T is equal to half of mu Wr, or T is equal to 0.5 mu Wr. Okay, so we will go to the next question. Belt velocity for maximum power transmission is A root over T by 3m, B root over T by 2m, C root over 2T by 3m, or D root over 3T by 2m. So you can pause and think of the answer. So the answer is A root over T by 3m. Now here what is T? T is the maximum tension in the belt, and what is M? M is the mass per unit length of the belt. So when the T and M are the maximum tension and mass per unit length of the belt, then the maximum power transmission is given by root over T by 3m. Okay, we'll go to the next question. When the axes of first and last gears are coaxial in a gear train, then it is called A. Epicyclic gear train, B. Compound gear train, C. Reverted gear train, or D. Inverted gear train. So you can pause and think of the answer. So the answer is C. Reverted gear train. So again, you can check the source if you have any more queries. So we will go to the next question. The gear train used in car differential is A. Simple gear train, B. Reverted gear train, C. Compound gear train, or D. Epicyclic gear train. So you can pause and think of it. So the answer is, it is an epicyclic gear train. Okay. So we will go to the next question. The rotor of a ship revolves in clockwise direction when viewed from the stern, while the ship is taking a left turn. Due to gyroscopic couple, the phenomenon occurring is A. Raising of bow and stern, B. Lowering of bow and stern, C. Lowering of bow and raising of stern, or D. Raising of bow and lowering of stern. So this is a question from gyroscopic couple. So you can pause and think of the answer. So the answer is D, which is raising of the bow and lowering of the stern. Okay, so we'll go to the next question. The height in meters of a watt governor is A. 8.95 by capital N square, B. 895 by capital N square, B. 895 N square, C. 895 by capital N square, or D. 895 into G by N square. Now this is pretty obvious, and this is taught while we are studying watt governor. This is the basic formula, so you can think of it. Pause the video. So the answer is C. 895 divided by N square. Okay, so we will go to the next question. The acceleration of the piston in a reciprocating engine is given by which is given by, we have to see the formula here. Omega, theta, r and n have their usual meanings. So it's given by what? A. Omega r into sine theta plus sine twice theta by n. B. Omega square r into cos theta plus cos twice theta by n. C. Omega square r into sine theta plus sine twice theta by n, or D. M omega square r into cos theta plus cos twice theta by n. So this is basically primary acceleration we are having, and also the secondary acceleration. So you can pause and think of it. So the answer is B. Omega square r cos theta plus cos of twice theta by n. So this is again, as I have told, it is the sum of the primary and the secondary accelerations. So we'll go to the next question. In completely constrained motion, A, the motion is completely restricted motion. B, the motion is in a definite direction. C, the motion takes place in more than one direction. Or D, the motion is not completed by itself but by some other means. So you can pause and think of the answer. So the answer is B, that irrespective of the direction of the force applied, in completely constrained motion, the motion is only in a definite direction. So one example is a square bar moving in a square hole. So this square bar can only go along the hole, but it cannot go any other ways. So next we will go to the next question. Question 13. If E is modulus of elasticity, G is modulus of rigidity, and K is bulk modulus, then the correct relationship among them is A, E into 3K plus G is equal to 9 kg. B, K into 3E plus G equal to 9 EG. C, G into thrice K plus G equal to 9 KE. Or D, K into thrice K plus G equal to 9 EG. So you can pause the video and can calculate it. So the solution is A, E into thrice K plus G equal to 9 kg. Now here I have given the derivation. You can pause it and check the derivation. And I have also given the source of the basic equations, that is the equation of G is equal to E by 2 into 1 plus nu, and K is equal to E divided by 3 into 1 minus twice nu. So after that, by simple arithmetic, we can solve it and we can find the answer. So we'll go to the next question. The elongation of a whole bar of rectangular cross section hanging at its one end freely under its own weight is given by. So here we have a rectangular bar of rectangular bar. Now it is hanging freely, and due to its own weight, how much it will elongate, that we need to find out. So whether it will be A, WL by 2AE, B, WE by 2AL, C, AL by 4WE, or D, WL by 4AE. So these are the four options. You can pause and think of it. So the answer is A, WL divided by 2AE. So if you have any doubt or if there is any calculations you need to check, you can check from the source. Okay, so we will go to the next question. If E is modulus of elasticity, G is the modulus of rigidity, and nu is the Poisson ratio, then the correct relationship among them is A, E is equal to twice G 1 plus nu, E is equal to G 1 plus 3 nu, E is equal to twice G 1 plus 3 nu, or E is equal to G 1 plus twice nu. So you can think, you can pause and think of it. So the solution is E is equal to twice G 1 plus nu. Okay, so we'll go to the next question. Leaf springs are subjected to A, tensile stress, B, compressive stress, C, shear stress, or D, bending stress. So you can pause and think of it. So the answer is leaf springs are subjected to bending stress. Now leaf springs are what? Leaf springs are a series of flats that are arranged in an inverted triangular form just above the wheels of very large vehicles like trucks or buses. So leaf springs are used extensively in trucks and buses. They are helical coil springs are not used there. They only leaf spring is used there. Okay, and so they are also subjected to bending stress. Okay, so in case in doubt, you can follow the source. So we'll go to the next question. Whenever the bending moment is maximum, the shear force is A 0, B also maximum, C minimum, D of any value. So you can pause and think of the answer. So the answer is, when the bending moment is maximum, the shear force is 0. This is one of the basics of the bending moment and shear force diagram. So in case any query is there, you can check the source. So we'll go to the next question. The point of contraflexure lies where? A, shear force changes sign, B, bending moment is 0 or changes sign, C, shear force is 0, D, bending moment is maximum. So you can pause and think of it. So the answer is, the point of contraflexure lies where the bending moment is 0 or it changes sign. Okay, so we go to the next question. The bending moment diagram for a cantilever subjected to bending moment at the free end is A, triangle, B, rectangle, C, parabola, or D, elliptical. So you can think of it. So the answer is B, rectangle. So if you draw the bending moment diagram, you will find that when we have a bending moment at the free end, then the bending moment diagram would be a rectangle. So we'll go to the next question. Widely used springs in automobile industry are A, flat spiral springs, B, leaf springs, C, closely coiled helical springs, or D, open coil helical springs. You can pause and think of the answer. So the answer is, as I have already discussed, it is leaf springs. So as I already told, leaf springs are extensively used in automobiles, especially in trucks and buses. So we'll go to the next question. The predominant effect of an axial tensile force on a helical spring is A, bending, B, tension, C, compression, or D, twisting. So you can pause and think of the answer. So the answer is D, twisting. So if you imagine a helical spring, if we have an axial tensile force, then it will have a twisting effect. Okay, so we'll go to the next question. 1 kg mass is connected to two identical springs of stiffness 20 kilonewton per meter, and these are fitted to a vertical wall. Now if the mass oscillates on a smooth horizontal floor, the natural frequency of the system will be nearly equal to A, 23 Hz, B, 32 Hz, C, 16 Hz, or D, 11 Hz. Now for this kind of problems, you first try to draw the figure and then solve it. So you can pause and try to solve this question. So the answer is B, 32 Hz. Here we have the springs, they are connected to a vertical wall, and we have this mass that is on a horizontal smooth surface. Now the equivalent K would be equal to K plus K is equal to twice K, which is equal to now 40 kilonewton per meter. Now omega n is equal to how much? Root over K equivalent divided by M. So omega n would be equal to 200 radian per second. So the natural frequency would be omega n divided by twice pi, which is equal to almost 32 Hz. So we will go to the next question. A simple vibration system has mass of 12.5 kg connected to spring of stiffness 1000 Newton per meter and dashpot with damping 15 Newton second per meter. The value of critical damping in Newton second per meter is A 223.60, B 0.2236, C 2.236 or D 22.36. So you can pause and think of the answer. You can solve it. So the answer is 223.606 Newton second per meter. So this is the spring, this is the damper, and this is the mass. Here we know the K is equal to 1000 Newton per meter, C is equal to 15 Newton second per meter, mass is 12.5 kg. So the critical damping would be how much? Twice m root over K by m, which is equal to 2 into root over Km. Now if we substitute the values, we will get critical damping is equal to 223.606 Newton second per meter. Okay. So we will go to the next question. Capstan lathes are used for A. Large batch production of jobs, B. Doing only one type of machining operation, C. Making jewelry parts, D. Making capstan of a sailing ship. So you can pause and think of the answer. So the answer is capstan lathes are used for large batch production of jobs. Okay, so this is from Workshop Technology. So you, in case you have any doubt, you can follow the source. So we'll go to the next question. Cross slide of a lathe supports A. Compound slide and compound rest only, B. Tool post and compound slide only, C. Carriage and compound rest, D. Compound rest, compound slide and tool post. So you can pause and think of the solution. So the answer is cross slide of a lathe supports compound rest, compound slide and tool post. So this is again a Workshop Technology question, as it is of the lathe machine. So this is, here we conclude this first part of the problem solving. We will bring the subsequent parts. So kindly subscribe to the channel so that you can find the next parts as soon as it is released. Thank you.